100 facts about the Milky Way to fall asleep to. Tonight, as you drift towards sleep, let your mind travel far beyond the worries of the day, far beyond the clouds and the nighttime sky, into the quiet, ancient story of our home galaxy, the Milky Way. Over 13.6 billion years ago, in the stillness that followed the birth of the universe, the first faint ripples of matter began to draw together. From these ripples, tiny proto-galaxies, the ancestors of the Milky Way, began to form like glowing seeds suspended in cosmic darkness. These early proto-galaxies were made mostly of dark matter, an invisible scaffolding that shaped their destiny. Though no one can see dark matter, it made up most of the Milky Way's mass, gently pulling gas and dust into place like a quiet, unseen architect. As these small building blocks drifted closer, they slowly collided and merged. The Milky Way began as many smaller galaxies combining, their stars swirling together over hundreds of millions of years. Every gentle merger added more light, more gas, and more structure. In the center of this gathering glow, a heavy, mysterious object took shape, a supermassive black hole, which we now call Sagittarius A. Even in those earliest ages, it quietly anchored the young galaxy, its gravitational pull helping to organize the stars around it. The first stars to ignite in these ancient clouds were unlike the stars we know today. They were enormous, some hundreds of times the mass of the Sun. These first-generation stars, called population 3 stars, burned quickly and brightly, leaving behind the heavier elements that future stars would need. As more stars formed, the Milky Way developed its halo, a vast faint sphere of old stars and ancient star clusters. Some of these clusters, called globular clusters, are nearly as old as the universe itself, shimmering in quiet orbits around the galaxy to this very day. Gradually, as gas settled into a smoother rotation, the Milky Way began to flatten into a disk. This was the earliest hint of the spiral shape we now recognize, like a celestial whirlpool forming in slow motion. Star formation continued, fueled by enormous clouds of hydrogen. Over time, these regions evolved into the Milky Way's spiral arms, not fixed structures, but waves of density where new stars are born, gently moving like ripples through water. Even now, the Milky Way is far from alone. It is part of a family of galaxies called the Local Group, dominated by the Milky Way and the Andromeda Galaxy. Our galaxy has always lived with companions, some large, some small, many of which merged with it long ago. And surrounding everything, from the bright heart of Sagittarius A to the faintest outer star, lies a halo of invisible dark matter stretching more than 1,000,000 light-years across, holding the galaxy together like a comforting cosmic embrace. And so, in these first moments of its life, the Milky Way wasn't yet the graceful spiral we see in images. It was growing, gathering, settling, slowly becoming home for hundreds of billions of stars, and eventually, one small blue planet. As you breathe slowly and deeply, imagine this galactic dawn. The soft glow of newborn stars, the gentle swirl of cosmic gas, a galaxy taking shape in silence. As the Milky Way settled into its early shape, time flowed quietly across billions of years, and the galaxy continued its slow, elegant transformation. With each passing eon, the Milky Way's disk grew broader and smoother. Gas and dust settled into a rotating plane, forming the thick disk, a region filled with older stars that orbit in slightly tilted, irregular paths, a fossil record of the galaxy's earliest days. Eventually, as the galaxy matured, a second layer appeared, the thin disk, the bright, smooth region where most star formation happens today. This thin disk is where the Sun, and most stars you can see from Earth, quietly travel around the galactic center. At the very heart of the Milky Way, a dense, glowing region formed, what astronomers now call the galactic bulge. Made of tightly packed stars, it is shaped like a soft bar of light, stretching across the center and gently helping to guide the spiral arms. Stars within the bulge move in complex interwoven orbits, some angled upward, some downward, like a cosmic ballet. These orbits tell us the bulge has lived many lives, shaped by early mergers, by starbursts, and by the swirling pull of Sagittarius A. As billions of years passed, the Milky Way continued to grow by gently absorbing dwarf galaxies, small companions drawn too close. Their stars were stretched into long, delicate stellar streams, still visible today as faint ribbons wrapping around the galaxy. One of the most famous of these is the Sagittarius dwarf galaxy, which has orbited the Milky Way several times, each pass leaving behind a trail of stars like a shimmering thread. Even now, it continues to blend with our galaxy in slow, graceful arcs. The Milky Way's spiral arms, though beautiful, are not solid structures. They are density waves, places where gas and dust move slightly slower, giving new stars time to form. These waves drift through the disk like soft pulses, encouraging star birth as they pass. Inside the spiral arms, star-forming clouds can stretch for hundreds of light years. Within them, clusters of baby stars ignite, creating brilliant regions called nebulae. Over time, the Milky Way has produced tens of thousands of these glowing nurseries. The galaxy also contains some of the oldest stars ever found, ancient, metal-poor stars that predate most of its structure. Some in the halo are more than 13 billion years old, silent witnesses from the Milky Way's earliest age of creation. And as the galaxy grew brighter, heavier elements created by dying stars spread through the disk. These elements, carbon, oxygen, iron, slowly enriched the gas clouds. Without this steady enrichment, planets like Earth could never have formed. The Milky Way was no longer a collection of small proto-galaxies, but a vast, luminous spiral, breathing slowly across cosmic time. With every star that shone, with every merger, with every drifting spiral arm, it became a place capable of nurturing worlds, and one day, life. As you rest, imagine this slow, majestic process. A galaxy learning to create the ingredients for planets, and eventually for you. As the Milky Way drifted through cosmic time, its spiral arms turned like gentle tides, quietly shaping the stars and planets that would someday fill its vastness. With each rotation, one full turn taking about 230 million years, the Milky Way carried its stars along in an elegant, slow dance. In all of Earth's history, the solar system has circled the galaxy only a handful of times. Over these long rotations, the galaxy continued gathering smaller companions. Astronomers estimate that the Milky Way has absorbed dozens of dwarf galaxies, each contributing stars, gas, and even globular clusters to its growing structure. Some of these mergers left behind subtle signatures, long trails of stars, slight shifts in stellar motions, and faint ripples in the disk. These galactic fossils help astronomers reconstruct the Milky Way's ancient collisions like a cosmic archaeological dig. One of the most dramatic mergers in our galaxy's past is called the Gaia-Enceladus event. Around 10 billion years ago, a large dwarf galaxy collided with the young Milky Way, adding many stars to the halo and causing a burst of new star formation. Even after these collisions, the Milky Way remained calm and stable enough to keep forming stars. Today, it creates about 1 to 2 new stars per year, quietly lighting the galaxy with fresh points of starlight. Star formation occurs mostly in giant molecular clouds, cold, shadowy regions where hydrogen gathers in massive, drifting shapes. These clouds can sprawl across hundreds of light years, forming clusters of stars that remain gravitationally bound for millions of years. Over time, many of these newborn clusters drift apart. Their stars disperse into the spiral arms, blending into the general stellar population. Remarkably, the Sun itself was born in one of these clusters, long since scattered across the galaxy. The Milky Way is a barred spiral galaxy, meaning its bright central region forms a straight bar of stars. This bar slowly rotates, gently pushing gas toward the center, helping to shape the spiral arms that wind outward like soft ribbons. Surrounding the disk is the circumgalactic medium, a vast halo of hot gas stretching far beyond the visible stars. Though nearly invisible, this halo contains more mass than all the Milky Way's stars combined, acting as a reservoir that feeds future star formation. And beyond the gas lies a deeper mystery, the dark matter halo. Smooth, enormous, and silent, this halo extends hundreds of thousands of light years, forming the gravitational foundation the galaxy depends on. Without it, the Milky Way would fly apart, but with it, the galaxy remains bound in peaceful rotation. In this stage of its life, the Milky Way had already survived great collisions, grown vast spiral arms, and learned to build stars in steady, rhythmic cycles. As you breathe slowly, imagine drifting with the solar system along its gentle orbit. Moving through the spiral arms, through quiet clouds of gas and ancient starlight, carried by the timeless motion of the galaxy. As the Milky Way continued its slow journey through cosmic time, its spiral arms curled ever so gently through space, forming the quiet environments where billions of stars would live out their luminous lives. The Milky Way contains between 100 and 400 billion stars, though no one knows the exact number. Many are small, cool red dwarfs, stars so faint that even in nearby regions, they can remain hidden from view. Red dwarfs are the most common stars in our galaxy, making up almost 3/4 of all stars. Their slow, steady glow allows them to burn for trillions of years, far longer than the current age of the universe. At the other extreme are the massive blue-white stars. Though incredibly bright, they live short, fiery lives, sometimes only a few million years long. When they die, they scatter heavy elements throughout the galaxy, enriching future generations of stars and planets. These massive stars often form in open clusters, groups of young stars born from the same cloud of gas. The Milky Way contains more than 1,000 of these open clusters, sprinkled along the spiral arms like beads of starlight. Some clusters remain bound together for long periods, but most dissolve over time. Their stars drift apart, becoming isolated wanderers orbiting the galaxy. The Sun is believed to be one such wanderer, long separated from its siblings. In addition to stars, the Milky Way is filled with nebulae, vast clouds of gas and dust shaped by stellar winds and radiation. Some nebulae glow with vivid light. Others remain dark, blocking starlight like gentle shadows. One of the most famous of these regions is the Orion Nebula, a bright star factory visible from Earth. It lies just over 1,300 light-years away, forming stars at such a rapid pace that it is considered one of the Milky Way's most active nurseries. But the galaxy is not only forming stars, it is also home to stars that have reached the end of their lives. White dwarfs, neutron stars, and black holes quietly populate the Milky Way, each a remnant of a star that once shone brightly. Some black holes roam alone, invisible unless they interact with surrounding material. Others exist in binary systems, gently pulling matter from a companion star. The Milky Way may contain millions of these silent black holes, drifting through the dark. Despite this vastness, the solar system occupies only a small, unremarkable corner of our galaxy. It lies about 26,000 light-years from the center, in a quiet region of a minor spiral arm known as the Orion Arm, a peaceful neighborhood far from the chaos of the core. And so, the Milky Way grew into a rich and varied home, a galaxy filled with ancient stars, newborn clusters, glowing nebulae, and quiet stellar remnants. A place where stars come and go, where clouds collapse into light, and where the cycles of creation continue endlessly, gentle as the breath you're taking now. As you drift deeper into rest, imagine our tiny solar system sailing through the Orion Arm, surrounded by distant stars, held safely within the soft, spiral glow of our galactic home. As millions of years passed, the Milky Way continued to evolve, quietly shaping the environments that would one day give rise to planets, moons, and the possibility of life. Within the spiral arms of the Milky Way, dust and gas slowly gathered into swirling disks around young stars. Over time, these disks formed planets, moons, and asteroids, creating countless planetary systems scattered throughout the galaxy. Astronomers estimate there may be 100 billion planets in the Milky Way, perhaps more. Many orbit small red dwarfs, others orbit stars much like our Sun. Some may be Earth-like, while some may be completely alien to anything we can imagine. Among these worlds are rogue planets, planets that drift freely through the galaxy without a parent star. They wander in cold darkness, pulled along by the Milky Way's gravity alone. The galaxy contains worlds of every kind: gas giants larger than Jupiter, rocky planets dense with metal, frozen globes covered in ice, and exotic planets with diamond cores or scorching lava oceans. The Milky Way's diversity is vast beyond comprehension. Despite this incredible variety, only a tiny region around each star, the habitable zone, allows liquid water to exist. In the Milky Way, billions of planets may lie within these gentle, life-friendly regions. As planetary systems formed, debris belts and asteroid fields developed as well. These regions, filled with rock and ice, occasionally sent material crashing into young planets. These impacts helped deliver water, minerals, and the essential ingredients for life. The Milky Way's environment is shaped not only by stars, but also by supernova explosions. These powerful stellar deaths spread elements like carbon, oxygen, and iron through space, materials crucial for forming planets, oceans, and even our own bodies. Some supernova remnants, like the Veil Nebula or the Crab Nebula, stretch for light years, slowly expanding and blending into the galactic medium. Their filaments and glowing arcs are reminders of stars that once lit their regions brightly. Cosmic rays, high-energy particles released by these explosions, constantly travel through the Milky Way. Though invisible and sparse, they play a role in shaping the chemistry of interstellar clouds, subtly influencing the conditions that lead to star and planet formation. Through all of this, the Milky Way has remained incredibly stable. Spiral arms shift, stars are born and die, and gas clouds drift. Yet, the overall structure remains intact. This stability, lasting billions of years, has been essential for creating a galaxy where life can arise and endure. The Milky Way is not just a collection of stars and planets. It is a living system, evolving, breathing, and recycling its materials across unimaginable stretches of time. As you settle deeper into rest, imagine drifting through these spiral arms, passing glowing nebulae, ancient star clusters, and distant worlds bathed in starlight. Feel the quiet hum of cosmic harmony, the peaceful rhythm that has shaped our galaxy for more than 13 billion years. As the Milky Way matured, its spiral arms glowed with new stars, and subtle motions within the galaxy continued to shape its evolution over billions of peaceful, drifting years. The Milky Way's spiral structure is not fixed. It slowly rotates, with each spiral arm moving at a different pattern speed. This means stars drift in and out of the arms over millions of years, passing through waves of star formation like travelers moving through gentle weather. The galaxy itself rotates at incredible speed. Near the sun's position, stars orbit the center at about 220 kilometers per second. Yet, because everything is moving together, the motion feels calm, steady, and unhurried. Despite these fast speeds, the Milky Way's shape remains stable thanks to the vast gravitational influence of dark matter, which acts like an invisible framework holding the spiral together. The galactic center, with its dense star clusters and powerful radiation fields, is one of the most energetic environments in the Milky Way. Stars there orbit Sagittarius A at breathtaking speeds, some traveling thousands of kilometers per second. Yet despite this intense activity, the galaxy's outer regions are quiet and serene. Out near the edge of the disk, stars move in slower, gentler arcs, and the night sky would appear darker and more spacious than from our own solar system. The Milky Way is slightly warped, shaped like a dinner plate bent at the edges. This subtle curve may be caused by gravitational interactions with nearby dwarf galaxies, or by the uneven pull of its own dark matter halo. In addition to being warped, the disk also vibrates, a gentle, oscillating motion set off by past galactic encounters. These ripples travel through the disk like soft waves through water, gradually settling over hundreds of millions of years. The Milky Way is a member of the Local Group, a small community of more than 50 galaxies. Most are tiny dwarf galaxies, but two giants dominate the group, the Milky Way and its neighbor, the Andromeda Galaxy. Between these galaxies lies a vast expanse of intergalactic space, silent, dark, and almost entirely empty. Yet, even here, thin wisps of gas and mysterious dark matter stretch across the void, connecting the galaxies with faint, invisible threads. Over time, gravitational attraction has been slowly drawing the Milky Way and Andromeda together. Billions of years from now, the two galaxies will merge in a slow, graceful collision, forming a new, larger galaxy, sometimes called Milkomeda. In the present moment, the Milky Way continues on its peaceful course, rotating, drifting, gently rippling with ancient gravitational echoes. As you breathe deeply, imagine floating above the spiral arms, watching the galaxy rotate in serene, silent majesty. Its motion steady and eternal, like the calm rhythm of your own heartbeat. Feel yourself settling into the quiet, resting within the harmony of a galaxy that has been evolving for more than 13 billion years. As the Milky Way sailed quietly through cosmic time, its stars aged, its nebulae shifted, and entire regions evolved like slow cosmic seasons. Stars in the Milky Way age at different rates. Small red dwarfs burn slowly, but massive stars live fast and bright. This creates a gentle stellar life cycle throughout the galaxy. Stars are born, shine, fade, and return their materials to space. When massive stars die, they sometimes collapse into neutron stars, objects so dense that a teaspoon of their material would weigh billions of tons. These remnants sail through the galaxy like tiny, compact embers left after a brilliant fire. Some neutron stars rotate rapidly, emitting beams of radiation. These objects, called pulsars, appear to pulse rhythmically as their beams sweep past Earth, like cosmic lighthouses shining across the Milky Way. The Milky Way contains many types of stars: blue giants, white dwarfs, red supergiants, and even exotic objects like Wolf-Rayet stars. Each contributes to the galaxy's story, enriching space with elements as they evolve. The galaxy's chemistry has changed dramatically over time. Early stars contained almost no heavy elements, but with each generation, the Milky Way became more enriched. eventually producing the carbon, oxygen, and iron needed for life. Throughout the disk, star-forming regions emerge and fade like gentle cosmic weather. A nebula may shine brilliantly for millions of years, then disperse into faint wisps as radiation and stellar winds blow it apart. Some nebulae become planetary nebulae, glowing shells of gas gently drifting away from dying stars. Though short-lived on cosmic timescales, they display intricate shapes, rings, bubbles, and filaments, formed by the quiet breath of a fading star. In the Milky Way, stars rarely live alone. Many belong to binary systems, where two stars orbit a common center of mass. Some systems even contain 3 or more stars, creating complex, graceful orbits that can last billions of years. The galaxy also contains runaway stars, stars traveling at unusually high speeds, ejected by supernova explosions or gravitational interactions. These wanderers race through the galaxy, tracing long, lonely paths between the spiral arms. Amid this motion, the Milky Way remains in delicate balance. Gravity pulls stars inward, while their orbital motion carries them forward. This harmony allows the galaxy to maintain its graceful spiral shape over billions of years. As these stellar processes unfolded, the Milky Way remained a place of constant renewal, where old stars gave their material to the next generation, and where the rhythms of creation played out over eons. As you breathe gently, imagine watching stars being born in glowing nebulae, seeing ancient remnants drift in the quiet halo. Feeling the peaceful continuity of a galaxy where nothing is rushed and everything unfolds in its own time. Allow the calm of the Milky Way to settle into you, like starlight resting on still water. As billions of years drifted by, the Milky Way continued to grow and transform, shaped by quiet mergers, drifting star clusters, and the slow, breathing rhythm of cosmic evolution. Throughout its life, the Milky Way has interacted with many dwarf galaxies. Some have merged completely, while others still orbit as satellite galaxies, such as the Large and Small Magellanic Clouds, 2 bright companions visible from the southern hemisphere. These Magellanic Clouds are connected to the Milky Way by long streams of gas, forming structures like the Magellanic Stream, a vast ribbon of hydrogen stretching across more than half the sky. The gravitational pull between these galaxies gently distorts them, creating tidal tails and streams. These features act like fingerprints of past interactions, offering clues to the Milky Way's history. Some dwarf galaxies orbit the Milky Way in coordinated patterns. This unusual arrangement has led astronomers to believe that the Milky Way's dark matter halo may not be perfectly spherical, but may instead be stretched or lumpy in subtle ways. The galaxy's star clusters also evolve over time. While open clusters disperse, globular clusters remain tightly bound, some containing hundreds of thousands of stars. Many globular clusters in the Milky Way are older than 12 billion years. These clusters orbit high above and below the galactic plane, forming a glowing halo of ancient starlight. Some clusters follow elongated, looping paths that trace the remnants of galaxies the Milky Way absorbed long ago. The halo also contains stellar streams, long, delicate trails of stars pulled from disrupted dwarf galaxies or globular clusters. Like cosmic threads, they wrap around the Milky Way in graceful arcs. The galaxy's motions are not limited to rotation. The entire Milky Way is traveling through space at about 600 kilometers per second, moving toward a region known as the Great Attractor, a mysterious mass concentration deep in the universe. Even as it moves, the Milky Way carries with it a faint glow called the cosmic microwave background dipole, a subtle temperature variation caused by the galaxy's motion through the relic radiation of the early universe. And yet, from within the solar system, the Milky Way appears calm and still. On a clear night far from city lights, the galactic band stretches across the sky like a softly brushed stroke of light, the combined glow of billions of distant stars. These satellite galaxies, tidal streams, and ancient clusters are reminders that the Milky Way is not isolated, but part of a larger cosmic community, shaped by quiet encounters and long, graceful dances of gravity. As you breathe slowly, imagine drifting alongside these companion galaxies, watching streams of stars arc across the darkness. Feeling the timeless motions of a universe that has been unfolding in peace for billions of years. Allow that stillness to surround you, soft and endless as the night sky. As the Milky Way continued its long, serene journey through cosmic time, its structure deepened. New stars continued to form, and the galaxy's quiet cycles of creation and renewal carried on without haste. The Milky Way's spiral arms are defined in part by star formation tracers, hot, young stars and glowing nebulae that highlight the arm's shape. These bright regions act like lanterns, outlining the galaxy's gentle spiraling pattern. Although we often imagine the Milky Way as a perfect spiral, its arms are actually slightly irregular. Some branch, fork, or fade unexpectedly, shaped by subtle changes in gas density and gravitational influences over time. The galaxy's central bar slowly rotates, completing one full turn in roughly 100 million years. This bar acts like a cosmic engine, guiding gas inward to fuel star formation near the galactic center. Near the core, stars are incredibly dense, far more closely packed than in our region of the galaxy. A star in the galactic bulge may have dozens of near neighbors within distances that would be unimaginable in our quiet part of the disk. Despite this crowded environment, planets may still form there, but the intense radiation and gravitational interactions near the center make the survival of life-bearing worlds far more challenging than in the galaxy's peaceful outskirts. The Milky Way also contains giant molecular filaments, long, thin structures of gas stretching for hundreds of light years. These filaments act as cosmic highways for star formation, funneling material into dense knots where new stars ignite. Interstellar dust, though only a tiny fraction of the galaxy's mass, plays a vital role. These tiny grains help cool gas clouds, shield molecules from radiation, and enable the chemistry needed to form planets and organic compounds. Some of this dust contains complex molecules, including organic substances like polycyclic aromatic hydrocarbons. These molecules drift through interstellar space, hinting that the building blocks of life are widespread throughout the Milky Way. Many regions of the galaxy contain massive star-forming complexes, enormous nurseries where hundreds or even thousands of stars may form within a few million years. These regions shine with ultraviolet light from newborn stars, shaping their surroundings like morning sunlight through mist. And yet, for all this activity, most of the Milky Way is quiet and dark. Between the spiral arms lie vast stretches of calm interstellar space, regions where few stars form and where gas drifts slowly, waiting for the next cycle of creation. All across the Milky Way, from the luminous spiral arms to the silent gaps between them, every region plays a part in the galaxy's story. A story of stars born from dust, of planets taking shape, of organic molecules drifting through quiet clouds, of creation unfolding in endless, gentle cycles. As you breathe deeply, imagine gliding through these calm spaces between the arms, drifting beside sleeping clouds of gas, surrounded by the peaceful hush of the galactic night. Feel the stillness of the Milky Way settle around you, soft as a blanket of starlight, carrying you deeper into rest. As ages passed and the Milky Way matured into its familiar form, the galaxy continued to move through space, slowly, steadily, and with a quiet grace that echoed across billions of years. The sun, like all stars, travels through the galaxy on a gentle path that rises and falls, bobbing slightly above and below the galactic plane every 30 to 40 million years, a subtle wave-like motion caused by gravitational interactions. During its orbit around the galaxy, the solar system passes through different spiral arms and interarm regions. These changes may influence the conditions on Earth over immense timescales, gently shaping cosmic weather around our star. The Milky Way contains vast superbubbles, huge cavities carved by clusters of massive stars. Our solar system currently resides within one such region called the local bubble, a low-density pocket created by ancient supernovae. Far beyond the familiar stars lies the outer halo, home to some of the galaxy's most ancient objects, fainted-out clusters and lone stars that orbit the Milky Way in elongated, looping arcs extending hundreds of thousands of light-years. The outer regions of the Milky Way contain stars that were not originally born here. Many were captured from dwarf galaxies long ago, leaving subtle chemical signatures that reveal their extragalactic origins. Even now, the Milky Way continues to grow. Gas flows inward from its halo, dwarf galaxies contribute fresh material, and new stars form continuously. The galaxy is not static. It is alive with slow evolving processes. Billions of years from now, the Milky Way and the Andromeda Galaxy will merge in a slow, majestic collision. Despite the two galaxies passing through one another, most stars will never collide because of the enormous distances between them. The final structure formed by this merger will likely be an enormous elliptical galaxy, larger and brighter than either of its predecessors. Star formation may briefly increase before settling into a long period of quiet evolution. Even after this great transformation, the Milky Way's stars and their planets will continue to orbit peacefully within the merged galaxy. The solar system may drift to a new position, but it will remain part of the grand cosmic story. And so, from its earliest beginnings as scattered proto-galaxies, through billions of years of mergers, starbirth, quiet evolution, and graceful motion, the Milky Way has become the galaxy we call home. A vast, spiraling sea of stars stretching 100,000 light-years across, holding our sun, our Earth, and every moment of our existence within its gentle, luminous embrace. As this story of the Milky Way comes to a close, let yourself rest in the comfort that you are part of something ancient, something beautiful, something that has been unfolding quietly since long before humanity first looked up at the night sky. Breathe softly. Feel the calm of a galaxy that has cradled life for billions of years, and allow its serenity to guide you into deep, peaceful sleep.